Hello, Samuel Stenerson. I did my project HTML5 based code injection attack. So introduction to HTML5 based apps. They're popular among developers for their cross-platform compatibility with little need for maintenance or for manipulation for use on specific platforms. However, because of this, it relies on middlewares like PhoneGap or Cordova for OS integration. So HTML5 based apps are developed using standard web technologies, and therefore they're more susceptible to injection. So code injection. It involves exploiting the app's interaction with external data sources. HTML5 based apps can process and display data from various channels, and thus attackers can embed malicious code into these data streams. So the app needs to be properly secured against such threats. If it isn't, it could execute malicious code into these data streams, mistaking it for actual instruction. And we'll see later on but why this happens in our case and how the example APK isn't properly secured. So this vulnerability is exacerbated by the fact that HTML5 apps, due to their web-based nature, treat data and code similarly, often processing them through the same channels. So this characteristic makes distinguishing between malicious and non-malicious code more challenging, increasing the risk of successful code injection attacks. So for our experiment, the objective to explore vulnerability to code injection via MP3 files and examine the vulnerabilities within the example APK that allow the injection. For the virtual device, we have a Nexus S API 17 running Android 4.2 Jelly Bean x86 architecture. And for my test device, it's Microsoft 11 x64 based desktop, AMD Ryzen 7 8 core processor, 64 gigabytes DDR3 RAM. Installing the APK and executing the script. So the example script given in the piano properties was a script to steal context through injection via an MP3 player, which is the example APK. So I have the script that's contained within the album artist property up top. So you can see to get the example APK onto the AVD, I did have to do a command line install, which worked just fine. So we were able to get the MP3 player onto the AVD. And then we can look and see that the script was contained in the album artist property of the MP3 file. And when you click load music in the MP3 player app, you can see that the script runs and the contact list is pulled. So I wanted to examine the example APK. So I decompiled it using JetX. I was looking for the entry point for the script in the MP3 file properties to see why it was allowed. So I'm assuming this is where it enters. When I was looking at the code, this seemed like the most reasonable spot, and the parameters matched up. So modifying the script. So with Cordova geolocation plugin, which is in the example APK, one could utilize this method to obtain the phone's or person's actual real-time location. Assumption is app permissions allowed location services. In our case, they do. So you can see the script there to pull the coordinates, and you can see it was successful in using the Cordova geolocation plugin to pull the phone's latitude or coordinates. And you can imagine how, if this was outside of a test environment and this data was being sent off to an external source, how dangerous this could actually be. Essentially, you could have somebody tracking your position or at least your phone's location at any point in time. Further capabilities of the example APK, when I decompiled it, I was just looking at what it could do, what kind of things it was touching, and it's kind of all over the place. It's got hands in everything. It's got Cordova plugins for network manipulation, for capturing image, audio, just very dangerous stuff. So how does this happen? So in examining the decompiled APK, we can see the potential channels these scripts could enter. And in our case, the issue is metadata handling. There is no sanitization. So the app does not sanitize or check the metadata of the MP3 file, and thus the script is successfully injected and ran. If there are no checks on these properties, these fields could be executed as scripts. Other ways this could happen is through WebView usage, because many HTML5 apps use WebView to render parts of UI. It also becomes a channel to inject malicious code directly into the HTML content of the WebView. And finally, I didn't find references to any CSP in the APK, which is another vulnerability. So in conclusion, the hands-on experiment has provided an understanding of the vulnerabilities present in HTML5-based mobile applications, specifically those extended through middleware. In our experiment, it was through Cordova. This experiment highlighted the extensive attack surfaces that exist beyond traditional web applications. The process of setting up the environment, the virtual device, and executing the injection attack through an MP3 file, and also analyzing the underlying structure of the MP3 player APK has provided insight into the methods and possibilities of an attack through injection. Furthermore, this experiment has provided insight into the unexpected channels a malicious actor could use to reveal sensitive information. And here are just the references I used. And that's it. Thank you so much.